Okay, well I've brought together a selection of different phone chargers just to highlight some features. That's what we're trying to do at the moment. We're trying to identify primary function features, and then we're moving slowly on to how actual technology inside the phone charger enables them to do their job properly. But essentially, all phone chargers that you get there are kind of, they call these wall warts. Okay, they're all mains powered phone chargers have the same inherent job, right? They need to take in mains voltage, so that's your 230 volts AC alternating current, and they have to convert it into a low voltage, so about 5.5, 6 volts DC. So inside here is a series of electronic components that do specific jobs, and we're going to be learning about those. But before I go into that, look, I just want to show you some of the features of these things that you may be aware of, you may not. So let's have a look, right? So, I kept this one when it was broken, just really as a demonstration to show you something. So you can see here we have a 3-pin system in the UK with our plugs, and one of these pins has come off, okay, and it was just plastic, okay. So this pin here in the middle was plastic. So this was what's called an unearthed plug, right? But that pin was serving a function, okay. So look, have a look at this, right? So without the earth pin, I'm unable to put that into a socket. The gates that take the live and neutral pins on a 13 amp plug are locked unless the earth pin, which you'll see is longer than the other two, goes in first, right? So when that in place, you can plug it in quite successfully. Okay, so let's have a look. Why are some of them metal and why are some of them plastic? Well, this is an earthed version. I don't know if it is actually earthed, but it's got a metal pin to it. So this earthed pin is always the first to make contact with a circuit, and it's the last one to leave. So essentially, as soon as that is joined to our earth bonding, which is a continuous circuit that takes any earth leakage, any stray voltage, to earth rather than travelling through us as a person and electrocuting us. So the earth connection there does a specific job. So that's one thing you might want to mention, okay? Mains products being earth and the functions and features of earth bonding. Right, next thing then. You may have noticed, you may not have, I'm not sure, these plastic shrouds or covers that go over the live and neutral pins. If you ever stop to wonder what they're for? Well, there is a time when the plug is being placed into the wall where live and neutral connections have been made, and this extension lead is not plugged in, by the way. If I was able to get my fingers around the side of that, once they were connected, I could electrocute myself. So those plastic shrouds, those shields that are there, are carrying out an important job, stopping me from being electrocuted. Okay, so we've looked at the outside of the plug, things like ergonomics and how comfortable that plug is to use. Is it easy to pull from the wall? We've looked at aesthetics. Is this a nice looking design? Geometrically shaped, quite regular sort of curves. This is an Apple one, by the way. But you want to have a look at other unique features, like for example this one where the earth pin is able to slide in to reduce the size of that if that was being taken away. Maybe that's useful if somebody's using that phone charger at work, or maybe taking it on holiday or something like that. So all of those little features might make that into a better product. Let's go back to this Apple one then for a second. So this one here has a trick of its sleeve. So this, look, section slides off. If I can do that. This section slides off. And this part inside here has the circuitry which can be used to create our low voltage DC circuit voltage supply, the USB, the female USB. But this one here picks up my UK power supply. So if that wasn't a UK power supply, then maybe what I would want to do is use a different plug that end, which could maybe fit into this part. So if I was on the continent and I had a continental plug sold by Apple with the same fitting mechanism on the back of that, I'd be able to put this bit into that and I would have a continental plug on the end of it, which might be quite a nice little feature. You don't see these that much anymore, but that is quite a cool little design. There you are. So let's have a look at what other features we can get from a phone charger. Now I've got to be careful with this one. This one here is, this one doesn't work. This is for micro USB, and it was designed originally to power Raspberry Pi. So let's have a look. We're going to go into the inside of this design in a bit. That's not really the bit I wanted to show you here. Like this phone charger has got an indicator LED on it. That's the feature that maybe you don't see on phone chargers. You don't really need it, do you? Because the phone tells you that it's charging. But there you can see on the side of the PCB board is a little LED that glows and then shows you the charge indicating state. It's also got an on-off switch in series with the connector, so you can turn it on and off. I don't know if any of those things are really needed, but they're there anyway. Okay, so above the line, below the line. Above the line, there are all those things that we just talked about: ergonomics, aesthetics, safety, and stuff like that. Let's have a look then at what goes on beneath the surface with a phone charger. Right, one thing you will notice, right, when you have a plug charger like this, is that they are designed not to be taken apart. There are no visible screws. It's clipped together and designed so that it's not able to be tampered with. You break it, get inside it, and your warranty is void. And if you do get injured, then you've got no comeback on anybody. So I have deliberately broken apart a phone charger. Now, I do not suggest you do this at home. Please, whatever you do, do not take a phone charger apart. It becomes very, very dangerous. Like, for example, that now could be plugged into an extension lead or a plug socket, and these two pins would have 230 volts across them. If you touch that, it would kill you. So you have to be really, really careful. Okay, but let's have a look at what's inside. So here's my plastic case, first of all. We can have a look at this now. You can see the sort of moulding that's been used. This is an injection moulded component, most likely made out of ABS plastic, acrylonitrile butadiene-styrene. It's a thermoplastic, so when you heat it up, it turns into a liquid, and you can squirt it into a mould or inject it into the mould, and that's where the name comes from. So injection moulded, it's heat resistant, it's very durable, it's tough material, so it takes quite a lot of force to break it. It's got good heat insulation, it's got good electrical insulation, and also it can be given this lovely sort of mottled finish, which is called spark erosion. Those are little sparks that are fired at the mould to just pit the surface a little bit, so that when you put the plastic into it, it picks up those little patterns, all those little features that you learn about. Just briefly look, if you pause to look at the outer side of this, you'll see things like British Standard safety numbers, CE, which is the Conformity European, and other safety marks that may be on here. Okay, so there, that's looking at the outside of the design. Right, over the next couple of weeks, we're going to be looking at what goes on inside the phone charger. So I don't know how close I can get and still be in focus. That's pretty good. So look, briefly, we have a female USB socket. That is our output. Our input is 230 volts AC, and that goes into these two wires that were hard soldered onto the live and neutral pins. There they are. So they were just soldered onto those two pins. Now they are on what's called a Jst Connector. So that's just a socket connector. But here's a bit of pokey-yokey for you. That can only go in one way round. You can't put it in the other way round. It won't fit. So pokey-yokey. Just taking away the human error in terms of designing. So let's have a look. When I like to think about how this system works, I like to think of it in terms of input, process, and output. So our input, 230 volts AC, right, alternating current coming through the mains supply, goes into the circuit board, and then there's a three-stage process before we get to our output, which is 6 volt DC. Okay, first stage, let's have a look. It uses this component in the middle, which is called a transformer. So just like Optimus Prime, it's basically a square donut shape made out of iron, a conduction, and it's got two windings. One side of it is wound with what's called the primary windings, or the induction windings, and then the other side has the secondary windings, and one side has more windings than the other. I'll put more theory notes up about this, don't panic. And what happens is 230 volts goes in to that AC, so alternating current, so fluctuating between plus and minus. It goes in, and out the other side comes 6 volts AC. So it reduces the voltage. That's the job of the transformer. Now, this wants to be DC. It doesn't want to be AC, okay? We want a steady, flat voltage coming out to charge our phone. So that being AC now is not quite right yet. So second stage then, we go into this little chip that's by the side here, and this is something we call a rectifier. Now, rectifiers come in lots of different shapes and sizes. This one's a little IC integrated circuit, but primarily designed for them would be a bridge made out of 4 diodes, not LEDs, not light emitting diodes, plain diodes that are designed to conduct electricity in one direction only. So they allow electricity on the plus side of the cycle and they block it on the negative side of the cycle. And what happens is you end up with a signal form that looks like camel humps, all on the plus side. So we're getting closer now. We've gone to our reduction through our transformer. So our step down transformer has taken 230 and made it into 6 volts AC. And then the AC 6 volts has been taken into a rectifier. The rectifier has made that into all plus, but it's still quite a noisy signal in terms of going up to from 0 up to 6, 0 to 6, 0 to 6, like a camel hump. So the last stage of the process then is smoothing, and that's what these tower bits do. These are called capacitors. So electrolytic capacitors that are designed to store charge and then release it very quickly. So what happens is on the upside of the camel stroke, the capacitor charges, and then on the downside of the camel stroke, the capacitor just feeds some of its voltage back into the system and takes the tops off, well, bridges the tops of the output signal, so it smooths it. So these are all smoothing capacitors that are on the side here. So there's our 3 processes. We've got the input that goes to the transformer to reduce the voltage, to the rectifier to make it all positive, and then to our capacitors to smooth out the signal. So that smooth signal is fed to the female USB socket, and that USB socket is able to take power to anything with a USB socket on the end. So that's our standard fitting, the USB. I mean, they mess around with the other side, you know, C-type, lightning, all the different kinds of connectors, but on the other end of it, they all have the standard USB fitting like this, even if they're USB 1, USB 2, USB 3. So I hope that made sense. This circuit board is a PCB, so it's a printed circuit board, and this is a mixture of 2 different types of soldering. Okay, so what it's got is the same kind that we did, where we drilled holes in the circuit board and poked the legs through and soldered them. That's called through-hole soldering. And on here you'll see also some small components that have been potted on the other side of the circuit board. These are called surface mount technology, SMT components. I mean, if you try and fix these, you're onto a losing wicket, really, because you cannot do that very easily if they come away from the circuit board. You have to be very careful. So this one's been soldered with a traditional through-hole method, but it's been done with a machine. Okay, so now I can tell that because the green that's on here is called solder resist. So that's printed onto the circuit board, and they leave gaps of bare metal where they want the solder to go. And then what they do is they flood a wave of solder over the circuit board. It only sticks to the bare metal, and it solders all those components in at the same time. It's called wave or reflow soldering, and it's very, very efficient in terms of putting just the right amount of solder onto the pieces. So you can see, look, there's no bridging short circuits. They're perfectly conical shapes, just what you're after, really, if you do your soldering. So, I mean, soldering by hand, you saw how easy it is to make short circuits accidentally by bridging components with blobs of solder, and that's just been made professionally. But same sort of technology, okay? So that's your PCB, your printed circuit board. Look, I'll put more notes out about it, but it's a good way to get started with an overview. These are below-the-line features of the phone charger, okay? We need to use technical terms when we talk about them in our annotation, our design sheets. So we're going to make some notes about what I've said. Watch the video, pause it, rewind it, write the certain terms down, you know, and then do some more research. And thinking, well, Mr. Owens mentioned transformer, pop transformer into Google, delete all the entries that come back with Optimus Prime and Bumblebee in. They're not the ones you're after. How does an electrical transformer work would be a good search. How does a capacitor work? Type in full wave rectification circuit and see what you get. On the images tab, you'll probably find some good ones that show you how the waveform changes at each stage of the process. There you are. I'll leave it like that. It's a pretty good video. I've gone over quite a lot of things there. Have a think about it. You've got to identify above the line and below the line features of a phone charger before you design your own.